we have a few examples here. We'll just kind of scroll through. Okay, so we have you. We have 5 people, maybe your family members. You have another 10 close relationships, and these are another 50. These are like your maybe co-workers, other people that you're pretty close to. And you have another 100 people that that are maybe just acquaintances, distant relationships, but you know them, you know who these people are. So this gives you about 150 people, and applying this to a network, a computer network, this can be crafted in a way to signal how trustworthy somebody is. So what you can do is you can set up a network where you have everybody on this network verify 150 different people as a minimum. And then every person on this network has to verify 150 people and be verified by another 150 people. And this verification process is a kind of endorsement. And so what happens when you do this is you build up a kind of web work of all these different connections. So I verify Joe, Joe verifies Anthony, Anthony verifies somebody else, and it goes on, and I can see a whole web of connections that stem out from where I am. So I can build a relative understanding of a network, and that can branch out in a very far-reaching capacity. And I can see, based on just 150 people that I have endorsed, who all else is out on this network by the people that they have endorsed and the people that those people have endorsed, and on and on. So with that being said, we'll get to the next slide here. And this talks about the rules for how you set up this network. There's 2 important rules that have to be followed. So all users will verify accounts to affirm that they belong to real individual persons. So that means that users who verify each other have to communicate outside of the network and say, is this your account? And then get confirmation, and then they can verify that account after they get confirmation from the real person who owns the account. Okay? And so by verifying an account, a user makes a public endorsement of the account, that it belongs to a real person and that they trust that this user will make no duplicate accounts and only verify accounts of other real persons. So when I verify Joe, I'm saying, Joe, I trust that you are only going to verify other people that you have verified in the same way that we communicated and verified. Okay, so as long as Joe stays to these 2 rules, and he goes on and he verifies Anthony, and then Anthony stays true to these 2 rules, and so long as the network itself is more or less secure, and you have some kind of security measure in place to investigate different malicious activities that may or may not happen, because you'll probably have those too. But there's ways that you can deal with that stuff. But this is the basis of how you establish a virtual system for identity. And it can be expanded on in a lot of different ways, but I'll get into a few different things that we can talk about here. So let's say that you want to conduct some kind of a trade with a stranger. Okay, and so they're using a currency on this blockchain, the same, and you're both on this blockchain together, but you want to make sure that this guy is somebody trustworthy. He's not only that he's using the same blockchain as you, that he's going to deliver whatever product you are purchasing, all of these things. You want to know that you're interacting with somebody that you can trust. So how do you check that out? Well, we can look at all of the connections, all of the endorsements that this stranger has received. And I can see over here that 30 of my friends have endorsed this stranger and said that, yep, this guy's a real person, and he stays, and he's following the 2 rules, which is to only endorse real accounts, to stay in line with whatever the rules are of the network, and so on. And beyond that, what we could also do is we could go a step further and investigate each one of these individual users here, these yellow strangers. And by doing so, we can get a deeper insight into, what percentage of these users are people that I know. So let's say that some of these users have like half of their endorsements come from my friends. Then I could say, well, this counts as a half user then. This isn't just one user, this is a half user. So that could bring the numbers up. Maybe it's more like 50 people are endorsing this stranger because of all of the endorsements that these people have from people that I know. So that would bring this percentage up to about a third. So that being said, you could also set, what the trustworthiness threshold is by determining what percentage of people do I need to know who have endorsed this stranger before I will conduct a trade with them. This could be decided on an individual basis or on a network-wide basis. So whatever governing body is in charge of this network can set the parameter for, what is a trustworthy person on this network. And you use that by setting this metric of a percentage of, how many people you have to know to interact with this person. Or let's say that instead of you, it's a state organization. They need to have a certain amount of connections before they can accept you in as a citizen of their state apparatus. So that's another way of looking at it. So, let's say that the threshold is set at, 10%. You need a 10% endorsement. Well, we got 30 people here, and let's say it's 50, so we have a third, we have 33%, okay? So that would qualify for a transaction. Now let's say you're interacting with a robot. So how do you figure out, whether or not someone is real? And this is kind of how you do it. Or one of many ways to do it. So here we have 2 people that I know have endorsed this account, 8 people that I don't know have endorsed this account, and 140 people that I don't know and that nobody that I know knows. So these yellow people, I have connections to people that I know, okay? These red people are not connected to anybody that I know. So this is a pretty good indicator that that this is like an insular kind of endorsement, and I can look at the connections of these people and who has endorsed these people, and if they're all like, let's say it's a clique of about 300 bots or something, then I could say, well, this doesn't look like it's connected to all of the users that I know and the users that I am connected to. So it looks like this maybe isn't I'm not comfortable with doing a kind of transaction with this account. So, and this may not be a robot, this may actually be somebody from perhaps the other side of the planet where there isn't very much travel and you just don't have connections to that part of the world. That could very well be the case too. So, but we're going to dig into this a little bit deeper and talk about this a little more. So we have 7 degrees of separation. This is another kind of social science theory that all people can connect themselves to anyone else on the planet by 7 degrees of separation over 7 different relationships or 7 different chains of relationships. So let's say I want to connect myself to Brad Pitt. I could find, one of my relationships, one of their relationships, and one of their relationships. I could do that at least, at the most, it would take 7 times to get to anyone on the planet. Brad Pitt in this case, right? So, this is a big part of how we can do more work to verify the identities of individuals. So all real users can be traced back to any user within 7 steps from any path. If this theory is true, then you could find a connection to any user on the network within 7 steps. That's all it would take. So we have you and a stranger, and then we have another stranger, another stranger, another stranger, another stranger, and then, here I am, I'm connected to this person. So all of these people could just be connected through these people that I don't know to somebody that I do know, and they are kind of just, as long as they're connected within 7 degrees, there's a degree of trustworthiness, right? Because it eventually gets back to me. The closer they are, obviously, this is like 5 degrees of separation. The closer they are to you, the more trustworthy they are, because there's less middlemen, so to speak. But this could also be a fair indicator, as long as the 2 rules are being followed, that people are only endorsing real human beings and their actual accounts, then this could very well be a functional model. So that would be an okay transaction, although it's less trustworthy than other closer relationships that I can see through at least this one user that I'm connected to this person in some way. So then let's say we have a robot. Now a robot is going to have a lot of connections to that are very insular. They are, because other people will not want to verify these accounts, because there will be penalties associated with it. I'm going to get into that a little bit as we go on. And maybe there's a few people in there that are kind of connected to me, but it's just it will be very, very easy to discover insular networks and to build like layers of who you're willing to trust, and to build a general picture and understanding of what a network looks like. And any of these kind of accounts that are very insular and are not connected to you in any substantial way, where you don't have a lot of connections, even going through these branches like this, that's a sign that this is probably somebody that you don't want to be trading with or interacting with. And this could prompt further investigation from the network, have the accounts deleted by some kind of governance body, some governing body, rather. But you can kind of get the picture here. It's coming into view. So the strongest connection is obviously the 1st degree. You have a stronger, which is a 2nd degree. And you could say that, as long as they have 50% or more, that this is a good connection. It's pretty much the same as a 1st degree connection. And then maybe as long as 50% of these users have 50%, then this is a good connection. You can set all kinds of different metrics with this. As long as you're just following these 2 rules and you're building these chains, you can set any kind of metric that you want. This is just for the sake of an example. And then you have weak connections that are 7th degree or more. Now this system is based on an algorithmic system that is very old, and I'm going to talk about that at the end of this video. Okay, and so on top of all of the algorithmic level of all of this, right, we can build a legislative layer, excuse me. So as a user on this network, let's say you're running some kind of a blockchain node. So you're performing services for the government because you're tracking a currency, you're tracking a state apparatus with user accounts, and you're verifying users. You're doing all of this stuff that is verifying the identities of individuals. So you're performing a kind of state service, right? You're doing something for a governmental body. So the governmental body may also choose, in effect, to kind of award licenses, right? So you can get another layer of identity security by having a governmental kind of body issue licenses to individual users. That adds another layer of security and trustworthiness to transactions and interactions. And ultimately, this is essentially just the old model of, you know, what we have with driver's license, social security numbers, and that it just works to have a central model for identity sometimes. You can have this distributed model that, like I showed you here, as a kind of auxiliary and just as a backup plan, but ultimately this kind of issuance of an identity really works very well. And but this is another way of doing it, where you have degrees of connections and you're establishing relational awareness. It's much more complex, and it takes a long time to deliberate about, and to, you know, to figure out exactly how to build something like this. But this is just another layer that you can add on top of it to make it even more secure. So now, that being said, you know, once you have identity established, you can start building some pretty cool things. So we're going to talk about currency here on this slide. Now, so this is Earth, and we have 7.6. Well, now it's 7.7, but as of the time I did these calculations, it was 7.6. So we're going to go through some stuff here. All right, so we have an adult population of, you know, 5.776 billion. That's 76% of the population. We have a birth ratio of about 2%, a death ratio of about 1%. We have a population growth ratio of, again, about 1%. Now we have a broad money supply of $90 trillion. So that's money that's circulating out there in the world, and denominated in US dollars. And then we have a derivative supply of approximately $1 quadrillion. That's stock market tools, cryptocurrencies, that's literally any kind of financialized asset that you can imagine thrown in with the broad money supply. So now this is pretty interesting. What we can do with these numbers is we can split them up according to the population. So broad money per capita gives each individual person $15,581.72. Okay? A derivative supply per capita gives each individual person $173,130.19. So this is a pretty interesting number, and and we can get a real understanding of where the value of our currency is at now by looking at statistics like this. And we can get a real understanding of how we can perform a transition from the old economy into a totally virtualized cryptocurrency economy. And I'm going to get into that a little bit more here on these next slides. So within this model, my theory of how this would work best is that each verified user should receive a static amount of currency once they get verified within a kind of state apparatus. Okay, so I send out 150 verifications, I receive 150 verifications. Once I do that, I create or the government, let's say, that I am a part of, issues to me a static amount of currency. It is always the same. It never changes for every person, you know, from now until the end of time. And if it ever does change, then retroactively the government has to either award or take away currency from users so that everyone is on the same level playing field. And I'm going to explain this a little bit more here. So let's say the government issues 10,000 units per user. Then 1 unit in broad money is $1.56 in today's broad money supply. If theoretically speaking, this currency had a global distribution, this virtual currency, and it totally replaced the broad money supply, then it would be at $1.56. That's what the value of that would be. So it's very precise. This is, this isn't guesswork. This is just based on what the statistics are. So, and if we use the derivative supply, then 1 unit would be $17.31, and every person would be awarded 173,000